Okay, this is a video for finding vertical asymptotes and holes. So first of all, some of you know this, but many of you are probably wondering, what is an asymptote? An asymptote is a line that a curve approaches but never touches. Here is a graph that shows both vertical asymptotes and horizontal asymptotes. The vertical asymptotes are the lines that go up right here, right, vertically. So these are the vertical asymptotes right here, going all the way up. And this as well, right? And the horizontal asymptote, there's only one of them, is right there, going across horizontally. So where are they? Well, the vertical asymptote is at x is equal to -1 and x equals +1. X equals -1 is, sorry about that, right here, and the x equals +1 is the one right there, because you can see that's where x is -1 and that's where x is +1. All right, sorry. And the horizontal asymptote, of course, is at y equals 1, which is right here. And there's also no slant asymptotes. We're not going to learn about that, but it is possible to have slant asymptotes. Okay, so we've already seen a graph with asymptotes before, because we have graphed y equals 1 over x, which we know looks like this. So we can see that there's both one vertical asymptote and one horizontal asymptote. The vertical asymptote is right here. The vertical asymptote is at x equals 0, right there. The horizontal asymptote is at y equals 0. So notice that, just like in the example above, the graph gets closer and closer and closer, but never actually reaches the x-axis or the y-axis. So it gets closer and closer and closer, but never actually gets there. That's what an asymptote is. Okay, so why do vertical asymptotes happen? Well, let's look again at our equation, y equals 1 over x. And we know that there's a discontinuity at x equals 0, because x equals 0 makes the function undefined, so x equals 0 is not in the domain. So let's look at what happens as we approach that point of discontinuity, x equals 0, from the right side, or the positive side. So at x equals 0, that's our y-axis right here, right? Right? So that's where x equals 0. So we're going to look at what happens as we get close and close to that over here on the positive side. What's happening over in this area here? All right. So if we look at x is 1, 1 over 1 is 1. Let's get closer to x is 0. So how about x is 0.5, 1 over x is 2. And if you don't know where these numbers are coming from, you can go ahead and plug them in and do the math yourself. X is 0.25, or 1/4. 1 over that is 4. So you can see that the 0.11 is going to be right here. Right? The 0.52 is right here. The 0.254 is right here. So you can see what's happening. It's getting closer and closer and closer. And of course, this is not a discrete function. It is continuous everywhere except for at x equals 0. So everything in between needs to be connected as well, right? So it's getting closer and closer and closer, but it's never going to touch x equals 0, because if it did, that would mean that there is a y value there, but there's not. It's discontinuous at that point. So at 0.1, we would have the y value of 10, which is off of our graph. 0.01, we are at 100. 0.00001, it's at 100,000. So you can see it's getting really, really high as we get closer to x equals 0 at from the positive side. And we can also look and see what's happening as we approach that point of discontinuity from the left or negative side. So let's look at x is -1. Well, our y value is going to also be -1. So we can go ahead and graph that point right there. And if -0.5, our y value is -2. -0.25, then y value is -4. Again, if you don't know where those are coming from, go ahead and do the arithmetic yourself and figure out what the y values are. So let's put those points on there. -0.5, -2 would be right here. And -0.25, -4 would be here. So again, you can see it's getting closer and closer. And as it's getting closer from this side, it's going down, down, down. It's getting closer and closer to x equals 0, but will never touch. That's what makes it x equals 0 a vertical asymptote. We're getting closer and closer and closer without ever actually touching. And we can see as we go here, -0.1 will get us -10, -0.01 will get us -100, etc. So that's what's happening closer and closer to that x equals 0. So that is why the vertical asymptotes are happening there. So vertical asymptotes happen at points of discontinuity when the graph approaches positive or negative infinity as the inputs get closer and closer to that point of discontinuity. Positive infinity, of course, is up. Negative infinity is, of course, down. So that means that if the graph is approaching positive infinity, that means it's getting higher and higher and higher and higher. If it's approaching negative infinity, it's getting lower and lower and lower and lower. So around our vertical asymptote, on one side, it's approaching negative infinity, as shown in the green, and on the other side, as shown in red, it's approaching positive infinity in this particular graph. So we can check for asymptotes by finding points of discontinuity and then looking at the behavior of the function around that point from both the right and left. In other words, how does the graph behave just to the right of that point of discontinuity and just to the left of that point of discontinuity? Okay, so let's do a practice problem here, find the vertical asymptotes of that function. So hopefully you recognize that there are 2 points of discontinuity there because there are 2 ways to make the denominator equal to 0. If x plus 1 is equal to 0, then 0 times x plus 6 will be 0. No good. If x plus 6 is equal to 0, then x plus 6 or x plus 1 times 0 would be 0. No good. So there are going to be 2 points of discontinuity, x equals -1 and x equals -6. Those are possible asymptotes. We don't know that they're asymptotes, but they possibly could be. In order to figure that out, we need to actually go ahead and check. So let's look at, as we get closer to -1 from the left or negative side. So when x is -2, y is -1.25. So x is -2, y is -1.25. And when x is -1.5, I'm getting closer and closer to that point of discontinuity of x is equal to -1. That's what I'm looking at right here. Okay, getting closer and closer to that. So at x is -1.5, I have our y value is -2.44. So as I'm getting closer to my point of discontinuity, I'm getting closer and closer to, it seems like it's going down. Let's see if that continues to happen. Right? So You can see these are our ordered pairs, and I'm going to go ahead and graph those and see what happens. So at negative 1.25, I should be all the way down at 4.84, negative 4.84, which is around there. At negative 1.1, we should be all the way down at 12. We're already off of our graph. So it looks like this graph is getting closer and closer to that x equals negative 1 and going down. And we don't necessarily know what's happening elsewhere, but we know that that's what's happening over there. Right? So it looks like we do indeed have an asymptote at x is negative 1. So there's an asymptote there. So we need to figure out what's happening close to that asymptote. We already figured out what's happening to the left. What's happening to the right? We can look over here, find points 0, 1.17. So that's right around here. And let's see if it starts heading up or down. So as we get closer to that negative 1, so negative 0.5, we get up at 2.36. So 2.36 is somewhere around here. And we can keep clicking and find out what's happening as we get closer and closer to that negative 1. It looks like it keeps going up and up and up. Okay. So we're getting closer and closer and closer without ever touching. So to the left, we're getting, when we approach from the left, it's going down. When we approach from the right, it's going up. Great, but we said we might have an asymptote at x equals negative 6 as well. So let's see what happens. Instead of checking all these points, let's just see what's happening as we get really close. So let's just check a couple. Negative 6.1 is at 1.76, and negative 6.000001 is up at 2,000. So that tells me that as we get close to x equals negative 6 from the left side, we're going to go up to positive infinity. So that tells me there is indeed an asymptote there. And it's going to be getting closer and closer and closer. And what about from the negative side? Negative 5.9 is negative 2.24. 5.99999, negative 5.999. It's hard to read that. There it is negative 2,000. So it's going lower and lower and lower, going to negative infinity as we approach that asymptote. All right, so somehow these have to connect in the middle because there are no more points of discontinuity. So I'm not exactly sure where it's going to connect, but let's just do this. And it might not be completely accurate, but you'll get the idea of the picture of the graph. Okay? We haven't talked about horizontal asymptotes and whether there are any or not, so we're really not sure what the rest of the graph looks like until we learn about those horizontal asymptotes. So there is, in fact, a horizontal asymptote at 1, I believe. So I think it's going to look like this and this, something like that. Okay, so we can check and see if our answer is correct. Here's a Desmos printout. There it is. Yep, looks pretty similar. That one looks pretty similar to the one that we have over here. Okay, I was wrong about where the horizontal asymptote was, but that's not what we're looking at. We're just looking at the general picture. All right, holes. So sometimes there's going to be, instead of an asymptote, a hole. So again, we start off finding the points of discontinuity. Here, it's a very similar equation, very similar function. We only have one point of discontinuity, x equals -6, because that'll get a 0 in the denominator. So that's a possible asymptote. In this case, it's not going to turn out to be an asymptote, and we'll see why in a second. So let's test it. We get close to -6. So here's -7, -6. So -7, -6 is going to be down here. And then we can keep finding other ones. -6.5 turns out to be -5.5. So that's going to be right there. And -6.25 is -5.25. So it doesn't really seem to be growing all that quickly. And if we were to graph all of these points over here, we are getting closer and closer, but it doesn't seem to be approaching, the y values don't seem to be approaching positive or negative infinity. In fact, they seem to be getting closer and closer to -5. Let's see what happens on the other side. So when x is -5, y is -4, which is right here. -5.5 gets us to -4.5. Right, so that's going to be right there. And keep going. -5.75 gets us to -4.75. So it seems the same thing is happening. We're not getting to positive or negative infinity. In fact, they seem to be narrowing in on this point of 5 right there. And in fact, that is exactly what's happening. So all these seem to line up just fine. So we can draw our line. So this, in fact, is a line. However, there is still this point of discontinuity. Sorry, let me move that. There we go. There it is. So our point of discontinuity is right there. That is the point where x is -6 and y is -5. Everything else just looks like a straight line, and it's just missing that one point. So that is not an asymptote. That is just a hole in the graph. It's a hole because x equals -6 gives us a point of discontinuity. And in fact, we're getting into an idea. This whole idea is getting into a little bit of what you will learn in calculus with limits. So as x approaches -6 for our function, we're going to get closer and closer to 5. So the limit of x going to -6 of our function is 5. I'm not going to test you on that right now, but I'm just giving you a heads up. So the limit of h of x as x approaches 6 is 5, but why does this happen? Why don't we have an asymptote? Well, let's look. There's our function. And look what happens here. The x plus 5s, I'm sorry, the x plus 6s cancel, leaving us with just x plus 1. So this graph up here is just the graph of y equals x plus 1, but with a hole in it because of this point of discontinuity caused by this x plus 6 in the denominator. So that's why we get a hole there. Everything else just looks like x plus 1. And in fact, if the hole wasn't there, it would just be x plus 1. Because if you plug in 5 into x plus 1, or -6 into, you'd get -5. So there's a mistake here. All of these should say -5, right? This is -5. Right? The limit is -5, not +5. Because if you plug in -6 for x here, -6 plus 1 is equal to -5. So x equals -6 is still not in the domain, because that's, even though we canceled it out in our original function, it was still there. So there's a point of discontinuity there forming a hole and not an asymptote. So the graph looks exactly like the graph of y equals x plus 1 with a hole at x equals -6. That's it. End of story. So you should have enough information to be able to answer most of the questions on your worksheet. Please do the questions in this homework.